Today we're going to read and highlight Lesson 1 of Unit 2, Earth Materials. So make sure that you have your student reader at hand or that you open up your version of Kami with the student reader. And let's open up to Lesson 1 on page 4, which is called Earth's Minerals. The Hope Diamond. A museum in Washington, D.C. holds the world's largest deep blue diamond. This 45-carat blue diamond is the size of a walnut. It is called the Hope Diamond. The Hope Diamond has long fascinated humans. More than 100 million people have visited the museum to see the diamond. It was first discovered in India in the 1600s, but its history goes back far beyond that. Scientists believe it is at least 1 billion years old and was formed so deep inside Earth that humans cannot travel there. How diamonds form. All diamonds are formed deep within Earth, at least 161 kilometers, or 100 miles below the surface. They can only form under tremendous heat and pressure. This heat and pressure are a result of Earth's structure. The center of Earth is a solid ball of iron and nickel. It is called the inner core. The core is 7,000 degrees Celsius, hotter than the surface of the sun. The outer core wraps around the inner core and is made of liquid iron and nickel. The mantle is located around the outer core. The mantle is the Earth's thickest layer. Imagine an apple. The core of the apple is like Earth's core, and the fleshy part that you eat is the mantle. Earth's mantle is an ocean of semi-solid rock called magma. It is here where diamonds are formed. Earth's skin is the crust. The solid crust is the coolest layer of the planet that forms the continents and holds the oceans. Diamonds are minerals. Diamonds are mostly made of a single element, carbon. The heat and pressure of Earth's interior causes the carbon atoms to join together in a way that result in the unique physical properties of diamonds. Diamonds are minerals. Scientists have found more than 3,000 minerals made up of different combinations of elements. All minerals are naturally occurring, which means they are not made by humans. They would exist on Earth without people. Minerals are also inorganic because they are not the product of something that was living or was once alive. Leaves and shells are organic because they came from something else that was once alive. They also have a definite chemical composition, which means that every mineral is made of the same number and kind of atoms. For example, diamonds can always be described by the chemical formula of C, since it's made of carbon atoms. Lastly, minerals have an orderly crystal structure. This means their atoms are neatly organized to form a repeating pattern. Identifying minerals. One of the reasons that people are drawn to the Hope Diamond is its color. Blue diamonds are very rare. They are blue because they have traces of the element boron combined with the carbon atoms. Diamonds come in many colors, including red, yellow, green, purple, and brown. Color is one property that scientists use to identify minerals. In addition to color, there are many other property tests that scientists can do to identify a mineral. For example, scientists were fascinated to discover that the Hope Diamond gives off a fiery red glow after it has been exposed to the ultraviolet or UV light. This is called phosphorescence. Scientists have learned that all natural blue diamonds glow red for about 5 minutes after being exposed to UV light. However, blue diamonds created by humans give off different colors. Because of this, phosphorescence helps scientists determine whether a blue diamond is real or fake. Other diamonds do not phosphoresce. Instead, they fluoresce, which means they only give off light as long as the UV light is shining on them. One of the diamond's most well-known properties is its hardness. Hardness is a measure of a mineral's resistance to scratches. Mineralogists use a 1 through 10 hardness scale called the Mohs scale. Talc is a 1, which means it's very soft. Diamond, in contrast, is a 10, making it the hardest naturally occurring mineral. It is so hard that only another diamond can scratch it. Its hardness is caused by the way the carbon atoms join together. The hardness of diamonds makes them useful for different applications. For example, they are used in cutting tools for military materials such as airplane parts and armor. Most diamonds are also excellent electrical insulators. This means they do not conduct electricity. Conductivity is tested by placing the mineral in a circuit and seeing if it conducts electricity. However, blue diamonds, such as the Hope diamond, are semiconductors. Depending on what other molecules are around, semiconductors can sometimes conduct electricity. Blue diamonds can sometimes conduct electricity because boron is a semiconductor. Diamonds are also excellent thermal conductors. This means they conduct heat. This is why diamonds feel cold to the touch. Scientists rarely rely on just one property test to identify when they are identifying a mineral. Many minerals share some of the same physical properties, including color and hardness. However, when many of a mineral's properties are examined, it often results in a unique set of properties that can be used to correctly identify the mineral. For example, in addition to hardness and conductivity, scientists look at a mineral's luster. Luster is the way light reflects off the surface of a mineral and how bright, dull, or greasy the mineral appears. Luster falls into two categories, metallic and non-metallic. Cut diamonds often have a metallic luster. This gives them a brilliant, freshly polished look. In contrast, uncut diamonds have a greasy or dull luster. Pure diamonds are also the most transparent known material. Transparent substances allow light to pass through. Pure diamonds are rare, however. Some non-pure diamonds are translucent, which means they allow some light through and absorb some light. Opaque diamonds absorb all light. Make sure you've highlighted all of our notes and then move on.